In this tip, I want to show you how to work a problem that goes backwards. Instead of giving you the angle and asking you for the arc length, it goes the other way around. It tells you the arc length and asks you for the angle. So the story is we have a circle with a radius of 6 meters. The central angle of the circle intercepts an arc of length 2 meters. Find the angle. So the concept is, of course, we have some kind of an angle here. We know this distance here, the arc length, that's being swept out by the angle. The angle, let's say, is theta, and we would like to compute this angle. Well, what we know in general is that the arc length is equal to the radius times the angle, where the angle must be given in radians. Now, in this case, we know that the radius is 6 meters. We don't know theta, but we do know the arc length. The arc length is 2 meters. So that tells us that 2 meters is equal to 6 meters times theta. Divide each side by 6 meters. And the meters cancels out. We have 1/3 for the angle. Now, that's not pi over 3. That is 1/3. So the angle is 1/3, and that in itself is 1/3 radians. That's a perfectly good answer. If we wanted to convert it to degrees, we could. We'd say 1/3 radians. To convert that to degrees, you multiply it by 180 degrees over pi radians. And of course, 180 divided by 3 is 60. The radians would cancel out. So we got degrees here, but it's over pi, right? Now, pi is a little bit more than 3. So this would be a little bit less than 20 degrees. If we want to convert that to a decimal approximation, we'd say 60 divided by pi is about 19.0986. And that answer is in degrees.